So let's talk about flow elements. Flow elements are instruments that are used to measure the flow of a fluid in a pipe. The most common type of a flow element is the flow orifice, which measures the flow rate based on pressure drop in the orifice. This is one of the typical details for a flow orifice in the P&ID. There are even more complicated arrangements, but we can just show it simple this way if we have a reference for typical detailed drawings. So here, if we see the detailed drawing of a flow element, we can see that it contains some valves which we should consider. But to make the P&ID simple enough, we shall just show it this way without valves. And when cross-checking its type, which is 1A, with the typical details, P&ID showing the details of 1A, which should be the one on the left, we can see the valves are considered. We shall talk about typical detailed drawings in a dedicated video later. Now, there are other types of flow elements, such as rotameters, Coriolis, ultrasonic, etc. The choice of the flow element type, or in general any instrument type, depends on many factors such as the nature of the fluid, whether the fluid is clean or fouling or viscous or corrosive. These parameters highly affect the choice of the instrument type. The instrument type also depends on process conditions like pressure or temperature. So some instruments work well at high temperatures or pressures, others may work at lower values. So this is an important factor here. The required range we want to measure. So if we want to measure readings where the ratio between maximum and minimum reading is 2 to 1, for example, this is a different case from measuring the range with a ratio of 5 to 1. So the minimum parameter, for example, the flow is 1000 and the maximum is 5000. This may be greater range and maybe not all types of flow elements shall fit for this range. If it is 10 to 1, then there will be very low types that may accept this range. So this is a very important factor when determining the type of the instrument. Also, another important factor that affects the instrument type is the required accuracy. So do we need an accuracy of 99.9 of the reading, for example, or we can tolerate a lower accuracy? Different types have different accuracies. Some types may have low accuracy, others may have very high accuracy, but this shall affect maybe the most important parameter here, which is the cost. So there are types which are very costly, but may provide the values we need, like accuracy or range or whatever the other parameters. Others are conventional, so they can be used for typical services that may not have very stringent requirements. So any conventional type can fit for purpose, and in this case, it will be more economic to choose. Sometimes we may have other constraints depending on our requirement. For example, if we want to install a flow element in a system where we want the minimum pressure drop, then we shall need a flow element that gives a very low pressure drop in order not to affect the whole process and the hydraulics of the system. So these can also affect the type choice as well.